So today what I'd like to do is continue with our lesson. You last lesson had the U-try. What I'd like to do is go over that, and at the same time I want to demonstrate for you the Java visualizer, which is kind of pretty cool. If I can find it here we go. It actually does different languages. It does Java, but it'll also do JavaScript and Python and Ruby, and apparently now does C++. That's pretty cool. We want Java 8. And you can write your code in here, give some type of generic class name to it, a public static void main for us. It's good for these types of things. You can't do a huge program in here, but it's good for testing these types of things. I have two different versions of this code in here. I have a while loop where I start with a Java counter equal to 0, and I'm going to add 1 every time. So 0, print Java, add 1, we're at 1, 0, print 1, add 1, we're at 2, 3, 4. When we change 4 to 5, 5 is not less than 5, so it stops. So this will only print a Java for index 0, 1, 2, 3, and 4. Now you could start it at 1 and then do less than 6 or less than or equal to 5. There's a couple different ways of doing that, but just make sure you are only getting 5 entries. The other way of doing it is to subtract 1 from 5 every time and making sure that we are greater than 0. Not greater than or equal to, just greater than 0. That's important to pay attention to those ending cases, to those boundaries, to make sure you're not going off the edge of your while loop. When we see for loops, we'll see similar types of things. So what's cool about this is you hit visualize execution, and it lets you step through the code. So there's clearly 47 steps. I can jump to the last, but we're going to go forward a little bit. You can see Java counter is 0. Java counter is 1. It says Java. Then it goes back up to the top. So when Java counter says 1, we get 1 Java. Java counter now says 2. We have 2 Javas. 3. Java counter now says 4. There's my 5th Java. So now I'm going to add 1 to 4 and get 5. But 5 is not less than 5, so it drops out of the loop. Did you see that? Let me go back so you can see it. Test the condition. 5 is not less than 5. Then it jumps all the way down to line 9. So I print version 2. And now I'm going to start Java counter at a 5. I'm just resetting the value. I don't need to declare it as an int again. I already did that up here at line 3. Go forward. Java counter is at 5. Print Java. Subtract 1. It's at 4. 3, 2, 1. Print the last Java. Subtract 1 from Java counter. We get 0. Go back up to here. 0 is not greater than 0. So we're done. It jumps from line 12 to line 17 to the end of the next statement. Okay? So Java visualizers are going to be very helpful as you go through some of your loops to help you kind of figure out the patterns. You can trace it all by hand, and you will have to trace it by hand on the AP exam. There's a lot of tracing code on the AP exam. We're actually going to spend our next whole lesson talking about how do you go through and trace code and what ways are there of organizing that so that way you can do that for the AP exam. So the other important thing to talk about is a new vocabulary word. It's called scope. Scope deals with what part of the program has access to a variable. Scope is a very big conversation in computer science. It takes lots of different forms, lots of different circumstances, and can get very tricky as to who, or I should say what, has access to the data in what variables, and furthermore, what can change data. Sometimes you might have access, but you can't change it. So the scope, our first introduction to it, really what we're looking for is these brackets. Anything within those curly cube brackets is within the same scope. And that's a very low-level understanding of scope to start with, but we're going to keep building that understanding as we move forward. A local variable cannot be accessed outside the block of code in which it was declared. So in our while loop here, if I had declared a variable in here, int and then in this while loop down here, I try to change tester. These two variables are in different scopes. They're in different sets of brackets. I cannot access this variable here because this is in a different set of brackets. Theoretically, it should give me an error, and there it is. Cannot find the symbol variable tester within this. And you might say to yourself, well, wait, I already declared it. You know, it should be fine, but it's not fine because its scope is inside this while loop. It doesn't exist anywhere else other than inside that while loop. So the way you would have to fix this is you would have to take this declaration int tester outside of that while loop and have it so it's at the same level of brackets everywhere. So it can be used at the highest level of brackets. So it is a nested type of thing. If you declare it up here after this bracket, then everything that's in this bracket, including both while loops, would have access to tester. But because the way I have it written here, tester is declared inside of this set of brackets here, or curly cues, whatever you want to call them, it's only accessible within this while loop. It's only accessible within these brackets. That's its scope. Suppose we decided to declare tester here as an int. So now technically we've declared it twice. Any other time we've done that in Java, Java had a major problem with that. Said, no, you can't do that. But watch. This was the last error. No problem. Jump to the last just to show you that it works. No issues at all. It works just fine. Notice, though, tester isn't there in my output. Let's take a look at this by stepping through it. We'll go through it fast, at least for the loops part. Oh, I thought it was going to put it up. I guess since we didn't change it. What's actually happening here is every time it's redeclaring the value of tester. It's not interfering with this one. These two values, even though they have the same name, are different. They're two different things, even though they have the same name. It's possible in Java to have two objects or two variables that have the same exact name in different scopes. And they're separate. They're not connected. So by affecting one, you don't affect the other. They're separated. So scope not only says you can't access them, if it's in a separate scope, you don't even know it's there. And that's a really important piece for Java to make it work. That's one of the reasons why we can have the scanner class and not have to know all the variables that are inside of it. Suppose they used a variable somewhere in their scanner class and you just happen to use a variable with the same name. If Java didn't allow for this separation of scope, you'd get an error. Because it would say, hey, wait, you already used that name. You can't use it again. So the fact that Java allows us to have the same name of variables in two different scopes actually is a fundamental piece of the way Java works. It's called encapsulation. That's that concept of keeping everything contained within its own scope. You can violate encapsulation. There are ways to do that, but you have to purposefully violate encapsulation and allow access to that variable through some other method. Okay? That part will come later. So if we take a look at this example here, we can see that int n equals 1908. It's within this set of curly cues. This is n is local to this block of code. N times equals 2, really, again, review of that unary operator. Multiply n by 2, assign it back to n, what that's saying. This is going to cause an error message because n doesn't exist outside this scope. N lives here. So we can't do anything with it outside those curly cues. It's outside the scope. We would get an error message there. Now what I would like you to do is go to Blackboard and write 5 lines describing what is scope. 5 lines describing what is scope. If you write 5 lines, you get the points. You don't write 5 lines, you don't get the points. Real simple. Straightforward. What is scope? There are 2 ways to end a while loop that we've talked about so far. First is through user input. This is a very common method to end a while loop. It's just keep entering values until the user enters in some type of flag variable to stop the loop. In this case, the flag is x, and the value that stops the loop is -1. So this loop will run forever and ever and ever until somebody actually ends the loop with a -1. Another way of ending the loop that we looked at is by running it a certain number of times. So we increment some type of counter, and the loop will not go past that counter. There's another structure that's good for this if you specifically want it to go 100 times, no more, no less. However, sometimes we want something to have a maximum number of times it can run, but it might jump out of the loop before that point. So that's where you would use a counter inside of a while loop where you're really representing either a maximum number of times run it's going to get to, and at some point it might get out of that. So those are 2 ways we've talked about how to end a while loop. But sometimes you screw it up and your loop doesn't end. And it's important in your development environment to know how to get out of an endless loop, because your computer has no problem with saying, okay, I will just sit here and do this forever. Ever and ever. Now, the brute force method, super brute force, would be to turn your computer off. That's one way of getting out of it. Very annoying. Another way would be to just do a Control-Delete and force the shutdown of Dr. Java. That's another way of doing it. The elegant solution is the fact that they have built in a way to stop the program from processing. Now, other computers do this with, like, they call it a break, where you stop the code, a hard break. You force the program to stop. They have buttons for it. Dr. Java has something a little less obvious. It's under Tools, and it's Reset Interactions. when you click that, if you're stuck in some type of loop, whether it's endless or not, maybe it's just a really long loop, and like, wait, this is just taking too long, I want to do something different. If you click that, it will stop the execution of the program and allow you to then get access to the code again. If you don't, you can actually still change code, but it's still running in the background. So you're not going to be able to run and recompile again. It's going to give you an error. It's going to say or something's already running or something like that. You're going to find some odd things happening. So if there's a possibility that you're stuck in an endless loop and you want to kind of restart from scratch, you go to Tools, Reset Interactions, and that will solve the endless loop problem. In Java Visualizer, if we did an endless loop, it actually times out in here somewhere. So if I take out, let's say, this counter here. Let me just take out this whole bottom loop here, because this is wrong. If I take out the counter and just let the loop go on without ever incrementing Java counter, right? That would be considered an endless loop. But the Java Visualizer actually only allows 10 seconds to execute the program before it says, yeah, no, sorry, this isn't going to work. So, dropped after running 1,000 steps, please shorten your code. It's not designed to handle long-running code. So that's where it ended up dying out. So Java Visualizer is nice in that it just won't let you go further. It'll kind of die out. Now, if your loop goes on for too many steps and it won't die, like it's designed to just be a really long loop, it won't work in Java Visualizer either. In Dr. Java will be happy to sit there forever processing your loop over and over again. So, let's jump back in here. Here's a nice bit of code. A common error here would be if someone were to accidentally forget the curly cues. This is how you could very easily end up with a infinite loop that you didn't intend. Right? Because it looks like the code is right. You know, you have your print, and then you do your x++, but what happens if you forgot those curly cues is that you get your while loop, and then it says print out Java, but since there's no curly cues, it goes right up to the condition again. So you may think that you've written a loop and it's good, but if you forget those curly cues, remember the idea of scope. The x++ would not be included in the while loop without those curly cues. Yes, I'm saying if I don't include them. So if I kind of cross them off here, you know, just cross them off. Yeah, not there anymore. Cross that off. Right? If I don't have them in there, then what's going to happen is I'm going to run this statement, go back up to here, test it, run this statement, go back up to here, run this statement, test it, back and forth, and I'm never going to get to the x++ because it's not within a curly cue bracket. You can do single line while loop statements just like you can do single line if statements. Why do they have that? It's not designed to mess you up. You have to remember, Java's not really a teaching language. There are specific programming languages that are designed for students to learn from. That concept of having a teaching language has died. We don't use them anymore because it has been found it creates bad habits and it ends up not really being as effective as originally planned. So the idea is, let's just dive into the real language. And you'll see that really single line while statements and single line if statements are really meant for the experts. You as a student have to understand how they're used, but it's the expert level programmer that's going to make good use of them. For you, it's more like your bane of your existence because it has a nice little spot there for you to make lots of mistakes. But they don't do that just to mess with you. Yes, they could very easily fix it and say, okay, everyone has to have curly brackets, but all the professionals who use this language will get very upset with that because it's 2 extra keystrokes. Actually, it's 4 because you have to hold down the shift key. And when you're typing thousands of lines of code, yeah, 4 extra keystrokes makes a big deal when you multiply that by how many ever times you write an if statement. Or a while loop that's a one-off, a single while loop. So that's the reason why it's there. It's not there to mess with you. It's there just because this is a professional language. You're learning a professional language. The old teaching languages, the original one, BASIC, B-A-S-I-C, basic, all-purpose, instructional, something or other code. Okay, BASIC is an acronym, stands for a teaching language. Pascal was another teaching language, not really designed to be used. So those have some safeguards built in where if you didn't have a curly Q or something, it was kind of okay with that. It worked okay with indenting. Python's another one where it has a little bit more flexibility. Not a teaching language, but it's just designed to be a little bit more flexible. Java and C# and other languages like that, not flexible at all because they're designed for professionals. It's the difference between using MS Paint and Photoshop. Okay? You know, we're out of the realm of MS Paint here. This is like professional version Photoshop. So the next step here, of course, is your exit ticket. I want you to do your exit ticket now. And then after you've completed the exit ticket, you can do the practice problems. You can do it in the template file that goes with this lesson, and you can just put all 3 inside the same file. Or if you want to do 3 separate files and submit them all individually, that's fine as well. I'm going to ask, though, that you also cut and paste your code into the written submission box. I want both. So paste it and give me the Java files. Sometimes I can figure out what's going on in your program just by looking at the code. It makes it faster to grade. Sometimes I need to run it if it's not structured the same way I expected or if it's just not formatted right. Sometimes I run it just to test it to make sure it would actually work and give you the benefit of the doubt. So I really need both at this point. You pasting your code into the interaction, into the written response, and uploading the .java file or .java files if you use more than one. And if you use more than one, just paste all 3 in. I'll figure it out. Okay? So go ahead, get to work on the exit ticket, and then move on to the practice assignment.